had some, uh, I decided to do some analysis, try to see if we can get uh, some kind of correlations between the different variables, see what we could build and find. It will require, unfortunately, some further data cleaning, which kind of makes me think, especially since I'm further along in this project, that you want to try to do as much of the prep work first before you start doing changes. So, and in this particular case, I want to say that the reason I say that is because I see that I had some issues from the join that resulted in problems for this particular analysis. So I want to just show you some stuff that I did here for this. So I have the pandas. I read the pickle. Take a look at the. Um, this is the same data frame. I just called it a data frame for analysis. I'm going to check to see if I wanted to. At first, I was like, you know what? I did it through NumPy, where this is actually a long, complicated process. Where I just took the column entries, turned them into lists, made them into arrays, and then tried to find correlations or coefficient of correlations between them. This is actually a lot simpler to just do it in pandas, but you need to make sure the data is clean first. So, for example, when you look at horsepower and you see for null values, there's 25 null values. I just went back to the original data frame, and I'll explain you. So basically, when I have like a null value for a certain entry, rather than to leave it, I can't leave it blank because then it can't run computations on them. So I just went to the original data frame, look at what the average horsepower, and then when there's an empty value, a null value, I did 125. Correct. Let's do 130. I know it's 125, 130. I mean, there's 25 entries, so it's not gonna make that much of a difference. Anyways, here's another issue that I sort of brought up earlier. I'll just leave it there. It's 125, 132. Here's the issue, which is that the horsepower variable is now an object, but in the original data frame, it's a float 64, so it's 64. So that basically means something happened to it, and basically what happened to is when I did the join, I don't really want to bring it up anymore. When I did the join for and to add the country, when there was a value that was blank, I called it undetermined, but it ended up rerunning, and then any blank value was undetermined. So the values in horsepower that were blank uh, entries were called undetermined. So I had to basically go in, set them. See right here, there's only 4 of them, but filtered out the the ones that see it says undetermined horsepower, and because of that, here right there, that's a string that changes the data type of horsepower from being a number that we can compute to something mixed because it has these strings here, so it can't calculate this thing right here. There has to be some kind of numerical value. So I just filled it in with here's where I did it. I filled it in with the average. So I just replace this with that, and then boom, I got as you can see, the data type changes to a float. And this is more stuff that I did that I didn't really have to see. As you can see now, the horsepower is now a float. So we can now use that to do computations. It's actually pretty straightforward. Uh, I just filter out for the variables that are numerical. So mileage, price, horsepower, country, years old. Uh, I didn't put in year because that's doesn't like years old is an actual quantifiable variable, whereas year is just a reference, so it's not. So, anyways, it doesn't have numerical value like 2011, 2020. The value between these two is that one of them's 9 years older than the other, not the actual 2000. So whatever. Point is, so I filter out this, apply correlation, and boom. But now we see how all the numerical values correlate with each other. So, look at mileage. It's obviously, one that sort of weakly correlated with price, which kind of makes sense. The more mileage, the lower the price you would figure, but it's not that big of a factor. Um, Horsepower, that wouldn't make any sense why those two would be correlated. So years old again, and this is all not that interesting because we don't really care about the mileage; we care about the price. And so we can see, okay, so there's a slight negative correlation with mileage, which seems to suggest that as the mileage gets greater, that drops the price. And it's kind of similar to the years old. So again, the older the vehicle, the less value it's going to have. But the only really sort of good correlation we have here is with horsepower, um, which, basically that kind of makes sense. People buy more expensive vehicles. They want to have vehicles that can go fast or have a nice engine like a V8 or something. So it just seems to suggest, that really when we look at the pricing, the only thing that we can literally look at that really affects it the most is what kind of an engine has the price or the horsepower. And I kind of try to break it down a little bit to see like, okay, what if we filter out to cars that are like less than 10,000 euros? All right. Well, right there we see there's almost no correlation. There's a very, very weak one with horsepower. So it seems like when people don't have that much money to spend on a car, they don't really care how fast it or how much power it has. And, that how old it is seems to make a little bit more of a difference than before. And these are all South Park references, by the way. So, again, here, okay, so it's over 10,000 euros. Yeah, there's a little bit more of a correlation between horsepower and price. Okay, but there's less between mileage and how old it is. So again, like it seems to be basically, uh, we just would figure, more expensive car, you're going to get more what you pay for. So you're probably going to get a stronger, a more powerful engine. And here uh, I just wanted to find how much variation there was in certain price ranges. Um, so basically, here, as you can see, is the more over. Uh, there's less variation as it gets more. Uh, so if it's under 60,000 euros, there's more variation, but as it gets over 200,000, there's less, which kind of makes sense. It's just they're going to be more powerful engines overall. So you have 650 on average horsepower for vehicles over 200 euros. You're going to have a lot less, 160, and then again. So basically, once you get into the luxury area, you're going to look at much more powerful cars. So that's not that interesting. I guess it's kind of what we would have expected. We just didn't expect that other factors wouldn't make as much of a difference. All right, so now I'm going to move on to looking at depreciation.